Qubit, there's a little smudge on the window, and it is really bugging me. Right there, see it? It's a tiny smudge shaped like a little ring. Hold on, let me just wipe it off.
I wouldn't bother.
Why not? It's right here on the glass.
Because that smudge isn't on the glass. It's about 10 billion years away.
Come again?
You could scrub all night. That one is not coming off.
Okay, what is it then?
That little ring is an entire galaxy.
A galaxy is not a ring, Qubit.
This one looks like a ring because something bent its light into a circle on the way here.
Vega and Qubit, and the galaxy I just tried to wipe off the window.
Quick question first. Which way does light travel?
Straight. Everybody knows that.
Dead straight normally, the straightest line there is.
So how do you bend the straightest line there is?
You put something heavy right next to it.
Heavy things bend light. With what?
With gravity, the same gravity holding you in that seat.
Gravity pulls on me, sure, but on light.
Einstein worked it out over 100 years ago. Gravity bends the path of light, too.
And did anyone actually check, or did everyone just trust the hair?
They checked. In 1919, during a total eclipse, they watched stars near the sun shift out of place.
The stars moved?
Their light bent in the sun's gravity and arrived a little sideways, exactly as Einstein predicted.
So the sun's been photobombing the stars this whole time.
Gently bending them. And that eclipse was the first real proof gravity can steer light.
Okay, but how does gravity grab hold of something with no weight?
Here's the part nearly everyone gets wrong. It doesn't grab the light at all. A heavy thing bends the space around it, and the light just follows the bent space.
Picture that for me.
Imagine a heavy ball resting on a stretchy trampoline, sinking a deep dip into it. Roll a marble past, and it curves around the dip. Nothing pulled it sideways. The floor was just tilted.
So the light thinks it's going perfectly straight.
It is going straight, through space that happens to be curved.
My brain just did a little dip of its own.
And one more thing. This is nothing like the glass in a telescope.
Why not?
Glass splits light into colors like a prism or a rainbow in a raindrop. Gravity bends every color by exactly the same amount, so the picture comes through true.
So it's not really a lens at all.
Not glass. It's the shape of space itself, a kind of cosmic mirage. Now stop thinking small and make the heavy thing gigantic, a whole galaxy. Park a faraway galaxy directly behind it, and its light bends around every side at once.
And all those bent beams meet back up.
Into a ring, a perfect circle of light we call an Einstein ring.
My smudge.
Your smudge.
I tried to clean a galaxy off the window with my sleeve.
History will be kind. Nudge the line up just a little off-center, and the ring breaks into separate copies instead. Of the very same object, one thing showing up in 2 or even 4 places at once.
The same object 4 times?
There's a blazing galaxy core, a quasar, that one galaxy splits into 4 neat points, the Einstein cross.
1 quasar, 4 reflections?
Not reflections. 4 real images of one light, each taking a different path around.
When did we first spot this stuff?
Back in 1979, 2 quasars sitting suspiciously close turned out to be 1 quasar doubled by a galaxy in front. Einstein saw it coming decades earlier. He knew a lined-up mass could make a ring. But he figured the alignment would be so rare that we'd never actually catch one.
Was he right?
Happily, no. The sky turned out to be full of them.
So what's doing all this bending? The galaxy I can actually see?
Some of it, but most of the bending comes from something you can't see at all.
Can't see it?
Most of the mass out there gives off no light whatsoever. We call it dark matter.
So you see the bend, but not the bender.
Beautifully put, which makes lensing a flashlight for the invisible. 2 clusters once smashed through each other, and the bending showed their mass had sailed clean past the glowing gas.
So the heavy stuff and the bright stuff aren't even in the same place.
Which is how we know most of the universe's mass is the stuff we simply cannot see.
That's equal parts amazing and a little unsettling.
Now let me be honest with you for a second. This trick needs a near-perfect lineup, so most of the sky isn't lensed at all.
So my ring was a lucky shot.
One lucky alignment in a sky full of millions, which is exactly why they're treasures.
Okay, besides looking gorgeous, what is lensing actually good for?
A lens doesn't only bend light, it magnifies it.
Magnifies, like a magnifying glass.
A whole cluster can act like a giant telescope that nature built for free.
How deep can a free telescope see?
Deep enough that the faintest, farthest galaxies we know were all found hiding behind lenses.
Show me the record holder.
There's what looks like a single star, magnified thousands of times by a cluster sitting in front of it.
One single star that far away?
Its light set off when the universe was a few 100 million years old, the most distant star we've ever seen. We can't be sure it's one star or a tiny huddle of them. We're at the very edge of what's possible.
A single candle halfway across the universe because gravity zoomed in for us.
Astronomers nicknamed it Arundel, an old word for morning star. And remember from last time, the farther we look, the older the light. So a lens is a time machine too.
A magnifying time machine. I love it.
But the wildest thing a lens can do takes us right back to those multiple copies. Each copy's light travels a different path, and different paths are different lengths.
So the copies don't all arrive at the same time.
Exactly. One copy can turn up years after another.
The same thing, running late.
In 2014, a star blew up in a distant galaxy, a supernova, and a cluster split it into 4.
4 explosions?
One explosion, 4 copies, arriving by 4 different roads. Then astronomers did the maths and said a 5th copy was still coming about a year later in one exact spot.
They predicted a rerun of an explosion that already happened?
Of a star that died long, long ago, and then they simply waited.
And?
Right on schedule, the supernova lit up again, exactly where they said it would.
They called the replay of a dead star, and the universe delivered.
Same death, 4 mail trucks. The last one just took the long way around.
That might be the best thing I have ever heard. You keep saying gravity bends light. How hard can it possibly bend?
Turn gravity all the way up to the strongest thing there is, a black hole. Get close enough and light doesn't just bend, it can wrap right around the darkness.
Light going in a circle.
That very first photo of a black hole, the bright ring is light bent all the way around a dark shadow.
So the ring is the bent light.
The hole shines with nothing. Everything you see is light from behind and around it, curved into view. We've now caught it twice, the giant in galaxy M87 and the one sleeping in the heart of our own Milky Way.
There's one in our galaxy and we photographed it.
By the very light it bends, which is exactly the bend I promised you last time. So look at your smudge one more time.
The ring.
A galaxy from the deep past, its light curved around the invisible, magnified, bent into a circle just for tonight.
And I almost wiped it off with my sleeve. Space isn't only out there, it's a lens.
Gravity doesn't just hold the universe together, it shapes the very light and hands us windows we never built.
All that light came the long way, bent around the dark, just to land in my eye tonight.
And you saw it.
So what do we do with a galaxy stuck on the window?
We go and find the thing that's bending it.
Wait, if gravity can bend light, can it bend time too?
Now you're really thinking like a scientist. Next time we find a place so heavy that time itself runs slow.
If your brain bent a little just now, same. Hit subscribe so you don't miss it.
Plotting a course straight toward the bend.
See you out there, explorers.